by U. So tube diameter d, that is pi d by 4, length is L. A length L of air moves through the turbine in T seconds, so L is U into T. Okay, so turbine volume is this. So air density, that is assume the standard 1.225. So mass density to volume rho AUT, and we know the kinetic energy is half m v square or mu square. So here we will place that mass, and then the formula will convert like this. The theoretical power is this one, rho is the density, and there is a Bat's limit. For that you have to go through the book, and in that book you can find there is a equation regarding this formula, and you can find that very simple step how come that factor is coming into the picture. That's called Bits coefficient. So maximum 59.3 is the power can be achieved from the any machine, like that. Gray color, blue color, red color, 0 to 25 meter per second, 0 to 25 meter per second. So I had seen many wind machines that operate in between 5 meter per second to 15 meter per second. So if wind speed is less than 5 meter per second, then auto off, auto cut हो जाएगा. If that is greater than this, then it will auto cut. And there is a yaw mechanism. You can rotate the wind machine blades any direction, and you can fix it. And when you start, I had seen the demo, they just move to the wind machine into different direction and then start play, and then machine will automatically come into the direction of the wind speed, and then it started rotation. So slowly the wind will rotate. It's not like that blades rotating so fast then power will generate it so high. No, slowly you can see that wind is rotating like that, very slow motion, and then power produced, and then you can use it, this power, like that. One example I have one example. So like that, you have to calculate the power of calculate the power in a wind moving with a speed 5 meter per second, incident on the wind turbine with blade 10 meter diameter. Chandras, you can use calculator. Okay.
Yes, sir. Yes, sir.
Calculate the power in a wind moving with a speed 5 meter per second, incident on a wind turbine with blades of 100 meter diameter. So how does the power change if wind speed increases to 10 meter per second? So first of all, we have to get the information, means how much power we can have it. So area means tan, that is 100 meter diameter, so radius is 50. So as per the formula, this is half a rho u cube, u or v, whatever you can assume in that velocity. So half that pi r square means pi 3.14. I will also do that. 0.5 multiply 3.14 multiply 50 meter square multiply density here is given in the question 1.2 kilogram per meter cube, 1.2, that is rho, and then velocity is given 5 meter per second. So velocity to the power, so I have 588750, and if I divide it by 10 to power 6, this is equivalent to 0.58875 megawatt. Okay.
Yes, sir.
So 0.588, that means approximately this is 0.6 megawatt is sufficient to meet the average electricity usage of about 1000 European household. And important thing is that if we just increase the velocity double, so velocity increase 5 to 10, So automatically that 8 times power will be increased. So now with respect to 10 meter per second, the power is 8 into zero point 0.6. That means 4.8 megawatt power will be produced. And second thing is that we also have seen many type of aero generator on the roof. आप लोग अगर देखें जनरली मिल जाते हैं शहरों में लगे हुए. So one we have at our department at the Deviala University campus. So we had installed one aero generator on the second floor, and that was hardly 10 meter on the pole. So second floor ka height, and then 10 meter above height, and then there is a aero generator. So that was moving so fast because wind is blowing at the time, and then power generated, and then that is stored into the battery. So if we have wind aero generator installation at home, if we have solar PV system installation at home, if we have biogas to produce the biogas, if we have biogas unit to produce the biogas for the kitchen purpose, fertilizer can use in our plants, then what else we need? Why we have to use the power from the grid? हम लोगों को ग्रिड का पावर का जरूरत ही नहीं है. One of my relative, my sister's home at Baroda, and they are having very large area, means on the roof, डबल स्टोरी है, और उसके बाद दे आर 3 ब्रदर्स बेसिकली, तो तीनों का बना हुआ है कंबाइंड, ठीक है, बट आपस में जॉइंट है, तो रूफ इज कॉमन. सो द वन गाय इज माय ब्रदर इन लॉ ब्रदर, younger brother, he had installed 5 kilowatt solar PV project on the house. 2 years before I had been there, I had seen that. And particularly this family, they are living separately, means सबके separate हैं, लेकिन रूफ कॉमन है क्योंकि आपस में रूफ मिला हुआ है. And he is enjoying life. Electricity is not a problem. Even in the Baroda town, power shortage is very less. बहुत rarely power जाता है. But whatever you are consuming as your lifestyle, you have to pay more and more. But in particular, this house section, they are not paying amount to the इलेक्ट्रिसिटी बोर्ड. भाई आपका जो मीटर लगा हुआ है इलेक्ट्रिक मीटर, उसका रेंट होता है, उसका रेंट होता है, तो उसके रेंट के लिए तो पे करना ही पड़ेगा आपको. बट यू आर नॉट पेइंग फॉर द इलेक्ट्रिसिटी कंजम्पशन. वॉट एवर इलेक्ट्रिसिटी इज नीडेड, सोलर पीवी सिस्टम प्रोड्यूस देमसेल्फ. सफिशिएंट है वो, इतना पावर सोलर से आता है, दैट इज सफिशिएंट फॉर देम, एंड दे आर हैप्पी विद दिस. They got subsidy, they got loan from the bank, and that's it. Hardly 50% they had spent from their side. And important thing is that, and they are loving to the environment. So they said, and question is here, that person is educated, basically he is lawyer. So I asked him, how do you know that this thing is going on? Who told you about this? So he said that he had seen through the newspaper, through the TV, and he is having some connection, means local connection. So somebody informed that your house is so big and you can also have such kind of installation. Then he decided, because education is not a barrier to him, so he decided very soon, and then he installed it, and now they are enjoying. Okay, so power output, this yeah, in that wind power generation, half, that means 0.5 rho a v cube Cp Ng Nb. Cp is the coefficient of performance, 0.59 bats limit is the maximum theoretical possible. However, 0.35 for good design. V velocity measure per second. Ng is the generator efficiency. 50% for the car alternator or 80% or more. So generation efficiency is very important. And Nb is the gearbox of the bearing efficiency, possibly high as 90%. So suppose you are getting power by step, and every step you are having such kind of 90%, 40%. So then overall you have to multiply that all efficiencies together, and then you will have it. Okay. So like this you can have. Yeah. And think that is coefficient of performance, COP बताया ना मैंने अभी आपको. And one more factor is the capacity factor. Generally we use 0.30, 0.40. That means like that 0.30 is capacity factor. That means 30% of the time wind machine is producing energy at rated power. And number of hours in a year कितने होते हैं? 365 into 24. 365 into 24, that is 8760. 8760 आवर्स हैं, और उसमें आपको कैपेसिटी फैक्टर का मल्टीप्लाई करना है. तो सपोज कैपेसिटी फैक्टर 30%, 0.3, that means 2628. So that much hours are only used to produce the power by the machine. So this is the calculation, that is the swept area, rotor blades, swept area pi r square. Acha. Now, generating wind power technology. So, type of the machines, horizontal and vertical. Horizontal and vertical. This is type of vertical. Drag is the main source. Knuckle is placed at the bottom. Your mechanism, lower starting torque, difficulty in moving, and that was basically that was basically yeah, yeah, in 1854, Daniel Halliday in US introduced a wind pump. A French engineer Darius built a aerogenerator at Bourget in 1929 that has a tower of 20-meter high with blades of the same diameter. In 1950, Danish Electrical Company successfully tested 200 kilowatt wind turbine. So like that, and such kind of development was going on, and that history is correlated with the oil war. Uh, means related to the oil, as we had discussed in the earlier. So suddenly the price rise of fossil fuel in 1973, and then find out the other alternative कि इतना प्राइस बढ़ रहा है, shortage of fossil fuels है, हो जाएगा in future, then we have to find some other alternatives. And then this sector expand a lot. Solar energy based sector and wind energy based sector means R&D started first, and after R&D the growth has been seen in that particular study, and now world is using that technology up to the land. Solar energy potential is everywhere, wind energy potential everywhere, technology is up to the mark. Now you can see, earlier I was talking about that maximum, the largest wind machine. So I just gone through one news, and that means Siemens launches 40 megawatt, 14 megawatt offshore wind turbine, world largest. And earlier I told you that I had seen one report that Norway is going to launch, one company in Norway, 10 megawatt wind machine. And then 14 megawatt model with 222-meter rotor diameter for the offshore wind farms. Offshore में लगा हुआ है. So that is the case study. अगर ये success रहता है, and then such kind of system will be installed one by one, and then lot of power can be produced. Similar kind of information is available. Same thing that plays many site. Okay, so this is also going on. So types of turbine, that is vertical. This is vertical axis type. Okay, and now you can see this is also vertical axis turbine. Upper half wires हैं, and those wires provide the strength. नहीं तो मशीन गिर जाएगा. सपोर्ट तो चाहिए ना उसके लिए. गियर बॉक्स, that is the vertical axis. Drag is good for low speed, or starting lift is needed for the high speed. That is horizontal axis wind turbine. Lift is the main source, much lower cycle stresses. 90% of the existing turbines are HAWTS. Mechanism is placed at the top of the tower. Your mechanism is required. Your mechanism basically कि किसी भी direction में है, तो that will automatically come into the direction of the wind direction. So like the typical HAWT, you can see here. यहाँ से चलते हैं हम लोग. Motor, this is the your motor, this is the your drive, this is the brakes, and this is the pitch, and gearbox, generator, and whatever section you are looking here. When you go to the wind machine, फिजिकली आप साइड पे जब जाते हैं तो इंटरेस्ट जगता है कि मैं जाकर देखूं तो सही कि ये है कैसी. सो देन देयर आर सो मेनी स्टेयर्स लगा हुआ है स्टील का, and you have to wear your safety jacket, and then one by one you will go to the top. and top पे आने के बाद आप देखेंगे कि ये एक बिल्कुल घर जैसा है, काफी स्पेस है अंदर, and you can have a look, ग्रिल लगा हुआ है सेफ्टी पर्पज, नहीं तो गिर जाएगा, कोई दिक्कत हो जाएगी. so that grill is over there, and then you can look around nearby. दूर दूर तक आपको सब कुछ दिखेगा क्लियर, because that tower height is so high. and whatever component you are looking in this slide, the similar thing you will see there. गियर बॉक्स में आपको दिखेगा कि गियर बॉक्स में ऑयल एंड ग्रीस लगा हुआ है, इधर वायर्स हैं, ये वायर्स हैं, प्रॉपरली जा रहे हैं, वगैरह वगैरह. एवरीथिंग इज प्रॉपरली मैनेज्ड. सो हॉरिजॉन्टल एक्सिस, this is such kind of small. We also had the same thing at our department just for the demo purpose. We use that electricity, but that we installed for the demo purpose, and that is 10 to 250 kilowatt village power hybrid system, and this is large. At Jamgodrani Devas, I had seen that time, means 250 kilowatt system and 500 kilowatt system machines, and the manager informed us that very soon they are going to get the highly based technology in the wind sector. So they had such kind of dealing with that, and those machine will come and old machine will replace and new will install. So later on, I did not go to that project. However, in 2009, 6, I had been there in the another sites projects. Modern small wind turbines, 50 kilowatt, 400 watt, 3 kilowatt, 1.8 kilowatt, like that. That is 7 years type vertical axis wind turbine. That is modern high horizontal axis. This is Gromil Darius V80. This is, and You see, such kind of 7 years vertical axis wind turbine. I had seen in Taiwan such kind of different thing. There is a hybrid system. So what they have, and wind is blowing so fast in that particular area because coastal areas in दोनों तरफ. आप ताइवान का मैप देखें तो आपको ताइवान चारों तरफ से समुद्र से घिरा हुआ है. So everywhere that wind speed is so good. So what they generally have, they they had installed everywhere the hybrid type system. Hybrid type system में basically photovoltaic and wind energy based unit. So those unit basically work together. तो wind तो 24 hours move करता है, तो हर वक्त बिजली बनाता है, and solar photovoltaic डे टाइम में ऑपरेट करता है. So what happened with the help of these units, that whole campus, the same thing installed in that university, Kunsan University, Tainan, Taiwan. I was there. So I had seen वहां पे इस टाइप का यूनिट हर जगह लगा हुआ है, सब रूफ पे लगा हुआ है, एंड बेसिकली दैट प्रोवाइड पावर फॉर द कॉरिडोर्स, फॉर द डिस्प्ले यूनिट्स, और वट एवर लाइटिंग अरेंजमेंट जो वहां पे हैं इवनिंग पर्पज के लिए, दैट ऑल ऑपरेटेड थ्रू दिस वन अरेंजमेंट. Like this you can have. So if that will move, so that will automatically, if train and if the bus will come and then wind speed will generate, then that will move like this. Turbine design, construction, blades, material used, typical length, tower height, so that's also very important. This is the underground electrical connections. This is knuckle with gearbox and generator, rotor blades. So here you can see अगर ब्लेड की हाइट ज्यादा हो जाए और टावर की हाइट कम हो, तो जब ब्लेड मूव करेगा तो वो जमीन पे छुएगा, या सपोज करो इतनी हाइट पे आएगा किसी के लग जाए तो कोई ये नहीं चाहेगा कि सेफ्टी पॉइंट हो. तो दैट्स व्हाई देयर इज सम डिफरेंस की हाइट, ब्लेड्स की जो लेंथ है और टावर का जो हाइट है, that must be properly arranged, calculation करके रखना चाहिए. So like that, wind turbine 50 times more powerful today than 20 years ago. Like yeah, that we had already discussed yesterday. So like that, vertical axis, such kind of wind machines installed. Three blades HAWT are most efficient. Two blade turbine don't require, and because you see the R&D work already had been done in that. I have one picture. So that is basically coefficient of performance, and that is 7 years and multiplied, that is various type. So efficiency, tip speed ratio versus coefficient of performance picture I have, and two or three blades propeller type machines is providing good result. Your mechanism to turn the turbine against the wind. Yeah, mechanism basically to turn the turbine against the wind. Yeah, error and fatigue loads. Use electric motors and gearboxes. Wind turbine safety sensors, control vibrations, aerodynamic braking, mechanical braking. So everything we have to be very careful. So how electricity flow? Wind turbine will move and that will produce power, and that power can connect it to the grid, or if that power going to use nearby the areas, so without feeding into grid in the remote areas we can manage. This is the hybrid type system. Wind side, this is photovoltaic, that is fuel cell alternative engine, and that will create power. Offshore turbines, more wind speeds, less noise pollution, less visual impact, difficult to install and maintain, energy losses due long distance transport. Like that offshore. आप जितना अंदर जाएंगे ओशन में तो डेप्थ ऑफ द वाटर इंक्रीज, सो यू हैव टू मेंटेन योर हाइट. उसको बेस बनाने के लिए आपको यू हैव टू मैनेज एंड यू हैव टू स्पेंड मोर अमाउंट. जमीन में तो लैंड एरिया में तो आप देख रहे हैं कि लेफ्ट हैंड साइड में ऐसे मैनेज हो जाएगा, बट इफ यू आर गोइंग shallow water if you are going, and depth 30 to 50 meter or 50 to 200 again, like this. You see so many projects installed like that. Advantages of offshore windmills: greater area available for setting up large projects. The wind blows faster and more uniformity on the land. So I will come to one student. किसके पास जाएं? Ashish Malik is available. Ashish Malik. आशीष नहीं है. अभिषेक पांडे है तो हाथ लगा उठाए. रेज योर हैंड. अभिषेक पांडे. अभिषेक पांडे नहीं है ये भी. कौन है क्लास में? खाली लॉगिन करके बैठे हैं. अनुराग. ओके, आई एम गोइंग टू अनम्यूट. यस अनुराग. हेलो.
यस सर.
हाँ अनुराग, ये बताओ, ये अभी तक हम लोगों ने देखा कि विंड एनर्जी में बेसिकली जो ऑनशोर हमने इंस्टॉलेशन दिया दैट इज अप्रोक्सीमेट कितना था? 38.68 गीगावाट. ओके. And at 80 meter height our potential is 103 gigawatt nearby. Okay, so there is still more potential in that. And I had seen few studies on that offshore windmill installation. So why in India we don't have that much installation in the country? What are the reason behind it?
सर ऑफशोर में कम हो सकता है क्योंकि उसके लिए ज़्यादा कॉस्ट की रिक्वायरमेंट होगी और ज़्यादा इन्वेस्टमेंट लगेगा कंपेयर टू इसमें ऑनशोर में.
Hmm.
और बाकी हमें बाहर की कंपनीज पे डिपेंडेंसी होगी सारे पार्ट्स पे जब तक वो विद इन द कंट्री जनरेट नहीं होते हैं.
Right now, condition is that many parts are available, means manufactured in the country. However, don't have any idea that Indian companies are manufacturing the wind machines or not. Maybe we have some plant, but that's based on that multinational based company.
यस
Okay,
सर.
but our several other companies providing their raw material to develop it. So question is that means why we are not going to have, and I had seen one study that India is also going to have a very huge potential of the offshore wind energy, because three sides we are also having the ocean.
यस सर.
ओके, तो गुजरात से लेकर आपका इधर से गुजरात से आइए आप महाराष्ट्र, महाराष्ट्र के बाद नीचे केरला, केरला से इधर तमिलनाडु की तरफ से निकल के और फिर आंध्रा और फिर ऊपर बंगाल की खाड़ी वहां तक जाएंगे आप तो समुद्री समुद्र है. So
यस
that
सर.
particularly belt can produce lot of power. So government also have planning for this, but right now they are not focusing on it. That phase will come in future. तो अभी क्यों नहीं कर रहे हैं? क्या रीजन है उसके लिए?
सर मे बी ये हो सकता है कि जो हम ऑयल इंपोर्ट कर रहे हैं उसमें उसकी कॉस्ट इससे कम आ रही हो जिससे अभी हम इस पे ही चलना चाह रहे हो.
नहीं नहीं नहीं, ऑयल का तो अभी देखिए, बेसिकली एवरीथिंग इज रिलेटेड टू द ऑयल, बिकॉज ऑयल प्राइस हाई. 100 रुपीज से ऊपर जा रहा है पेट्रोल, देख रहे हो आजकल न्यूज.
हाँ सर.
So in future that will be very difficult. And one more thing, every day I am watching the advertisement in one channel that Delhi government is promoting that electric vehicles, electric bike, electric auto, electric cars, uh, like that we can use it to in favor of clean environment.
यस सर.
कॉस्ट नहीं आ रहा है उसका, वो दे डोंट प्रोवाइड इंफॉर्मेशन रिगार्डिंग द कॉस्ट, बट दे आर सेइंग दैट विद द हेल्प ऑफ दिस वी कैन क्लीन द एनवायरनमेंट। बाइक भी है, ऑटो भी है और कार भी है।
जी सर।
तो अभी बेसिकली जो मेन थिंग है कि हमने ऑन शोर का टारगेट चल रहा है, एंड विद इन द कंट्री द पोटेंशियल इज वेरी हाई, हाउएवर वी आर जस्ट इंस्टॉल्ड कितना है हमारा 38, 38 और 103,
यस सर।
103 में 38 करेंगे तो अप्रोक्सीमेट 1/3 होता है, 35 से 105 होते हैं, 35 इंटू 3 105 है ना। तो अप्रोक्सीमेटली हम लोग 1/3 पे ही हैं। ओके,
जी
सो
सर।
जब still we are not getting the properly target, whatever
यस सर।
achieved 60 gigawatt is the target by the government, and
अभी
38 we have it अभी का जो है।
सर, अभी तो हम लोग ने ज्यादातर तो गुजरात और तमिलनाडु में ही यूज किए हैं विंड
सो
पावर।
स्टिल मीन्स अगर 22 गीगावाट हम लोग मोर ऐड कर देते तो देन वी विल बी एट 60, 38 to 40 and 40 plus 20 60 gigawatt पे पहुंच जाएंगे, and still we will have 43 gigawatt more potential in different states. So we will go for this first, and slowly as few projects started for offshore, so then we will move into the offshore energy. And you see, uh, right now we are fulfilling that onshore, and then we will move to the offshore, and then country will have approximately 200 gigawatt power by the wind energy in the country. और ये सब कुछ जो होगा अप्रोक्सीमेट 15 to 20 years में होगा अभी। Otherwise we don't have any chance to get more power, because everywhere we are going to have the solar power. So solar power में भी saturation आएगा, क्योंकि एवरीवेयर वी जस्ट ऑक्यूपाइड द रूफ, सब जगह पैनल लग जाएंगे, सब जगह सिस्टम लग जाएंगे, सो वी विल नॉट हैव मोर एरिया। ऐसा थोड़ी ना है कि हर जगह सोलर पीवी लग जाएगा।
यस सर।
So then we have to also think about this. So that's why all sector need to grow fast. बायोफ्यूल्स है, बायोमास है, बायो सीएनजी है एवरीवेयर। एंड सपोज किसी को बायोगैस से खाना ही बनाना है, उसको जरूरत ही नहीं सीएनजी की, क्योंकि उसको मेन प्रायोरिटी तो खाना बनाना है। तो वो बायोगैस से खाना बनाएगा या बायो सीएनजी में डालेगा, उसको उसकी प्रायोरिटी खाना है, तो दे विल यूज फॉर कुकिंग पर्पस। एंड इवन दैट ऑयल सेक्टर, मार्केटिंग ऑयल कंपनी जो है, उनको क्या चाहिए, उनको सीएनजी चाहिए, तो दे विल फोर्स देम टू प्रोवाइड द मोर सीएनजी। बायोगैस को लाइए, बायोगैस को आप इंप्रूव कीजिए, उसकी इंप्योरिटीज, उसमें से वाटर वेपर्स निकालिए एंड CO2 निकालिए एंड अदर गैसेस निकालिए, एंड देन प्रेशर इंक्रीज, एंड देन यू विल हैव द सीएनजी वैल्यू व्हिच कैन feed into the vehicles. So like that, and many BTTC are going on in the country to provide the information. Awareness program chalta ja raha hai. Is still more needed in the remote areas. You see, the sources are in the remote areas, and where we have to put more trust. And education is the main barrier in that area. Okay, so
यस सर।
that's it. Okay,
ओके।
so greater area, the wind blows faster, intensity of the wind is speed, and is steadier and heavier in the deeper waters. Longer windmills life approximately 23 to 30 years. No noise pollution, because remote ocean में है तो वहाँ तो कोई रहता ही नहीं है. Cost, of course, the cost is high. So such kind of drawbacks are also there. That is construction skill sets like that we have to manage like this. So installation like that. So turbines like this, and then transformer that will connect to grid, and then that will go to the site through transmission lines. This is the waking form. So more than half of the new wind power capacity in Asia. China, that is going to touch 250. 250 तो क्रॉस कर दिए वो लोग, ज्यादा है, 275 से ऊपर है. This is 651 gigawatt power overall in the world by the renewables. So every year 50-60 gigawatt बढ़ रहा है and China contributed lot. China और US मिला के कुल 40 gigawatt एडिशन दे रहे हैं हर साल. Okay, so like that, a service technician skills as commissioning operations. So like that, such kind of model installed at the base of the tower. Tower में सबसे नीचे installed होता है system. So a trained engineer, junior engineer, they can test it. So like that, safety kits आपको use करना पड़ेगा to go to the site. अगर आपको ऊपर काम करना है तो then you have to wear the safety kit. So like that, this is the new design. So when the wind is blowing, then that will convert power. So like this, the below picture is the thermal pollution, COX, SOX, air pollution, and then you can see here very neat, clean environment by the wind energy. Pictures difference you can identify clearly. Okay, so that's all for today lecture. है ना? So this is all by today's lecture. So if you want to quit, you can. I will close this at 11:15. Okay.